Hello everyone and welcome to Geography 411 Intermediate GIS. I am your professor for the semester, Nicholas Sokol, and it is a pleasure to have you in the course. I wanted to make this video really quickly just to kind of go over the syllabus and some of the course content, as well as describe how the course will be run and describe to you any technology that you may need in order to be successful in the course. So right off the bat, I just want to say this is an online course. I know a lot of you had some questions about whether or not this was a online or in-person course. The main content of the course will be served online, but there is a in-person component, which are the labs. And what I want to say right now about the labs, and this is kind of tentative at the moment, so it may change, but the labs are essentially there to help you if you are struggling with Python or completing the labs. You can go and ask questions and you can have them answered. You can get feedback on what you have completed in person. I will not be in charge of running the labs. We have a TA who is in charge of running the labs, and I will make introductions with this person soon. It's important to remember that because the course is asynchronous, it means you can work through the material as I post it and on your time. So while there are deadlines that you do have to meet or you will be hit with late penalties, you can work through most of the material as it is available and as you have time to do so. And it's important to also remember that that in-person lab component is really there just to be helpful for you if you would like to get a deeper understanding of the material and maybe go over questions in the labs or reflections that you're confused about or would like some extra clarity on. I'm also available during office hours. The office hours are going to be 12 p.m. to 1 p.m. On Tuesdays, and that means I will be mostly available via Zoom. So if you just pop into our Zoom room, you'll be able to reach me during office hours and communicate with me. Another thing I want to point out is this course is going to be conducted via Python. I've had a lot of individuals who have taken other courses around GIS that have done it with ArcGIS and ArcPro, ArcMap. The reason why I shifted to Python is because I feel that Python provides an advantage over ArcGIS. It's completely open source. You can continue to use it once you leave the university, whereas Esri's ArcGIS and ArcPro requires a license in order to continue using it. And so by allowing you to use Python, you can keep practicing the skills that you go over in this course. Additionally, all of the code that I provide to you in this course through Python, you are allowed to keep and use however you want. And so that also gives you kind of a leg up in terms of continuing to develop your skills within GIS and Python itself. Whereas opposed to ArcGIS, once you leave the university and you lose your license, unless you get a job in which you're using ArcGIS on a day-to-day basis, or you pay for the license out of pocket, which most of you probably will not do, you will likely not interface with that software outside of a university setting or an employment setting. So Python, I just feel, is the superior tool to introduce to you all to conduct a lot of GIS operations. And I assure you that we will still create products that are on par to ArcGIS. If you are still interested in utilizing ArcGIS, I do want to say that Esri Online does have a online kind of tutorial that you can utilize resources or something. There's Esri Open School that you can go to in order to kind of follow through to get some of those tools that you want to learn how to use. But at the end of the day, You can pick up Esri software pretty easily. It's a user interface guided tool. It's not hard to learn how to use Esri software by any means, and so I feel it also behooves you more to use Python in this course. So for a course description, again, we're bridging traditional GIS skills with modern Python programming workflows. So you're going to be learning GIS, performing spatial analysis, handling and opening shapefiles, conducting attribute queries on spatial data sets, learning how to handle and manage vector and raster data within Python, using Python. But it's all going to be Pythonic. It's not going to be using ArcGIS. So that's really the key thing here. If you've taken a prior course, this is really going to expand upon the skills that you gained in the prior course. This isn't meant to be an introductory or intro. This first week and next week, we're going to kind of be covering or recovering ground that you may have already been exposed to in a previous GIS course. But the main intention really is to give you new skills and exposure to new techniques that you have not been exposed to before. So if you haven't done any GIS and this is your first time being exposed to it, I do have some resources on the canvas that you can utilize in order to brush up on your skills. And so I have some Python and GIS. I have some QGIS, geospatial statistics, and cartography. But I also have GIS fundamentals refresher down here, and for other Python resources for those. Most, I assume, have not utilized Python. But if you have, then maybe you don't really need a lot of these resources. But if you are not familiar with the fundamentals of GIS, I would say definitely take a look at those resources. Okay, so learning outcomes. By the end of this course, students will be able to read, process, and visualize spatial data using Python libraries such as GeoPandas and Rasterio, automate GIS workflows using Python scripts and functions, perform spatial joins, raster calculations, and spatial statistics programmatically, access and process GIS data from APIs, build interactive web maps with Python, develop and present a Python-based GIS final project that addresses a spatial question. And so all of these are going to come at you from either the labs or the weekly reflections. The reflections are meant for you to do exactly what the word reflection means, reflect on what the content of the week was, and that's in an applied manner. My teaching style is typically in a very applied focus. I believe that by doing, you learn the most. So I can bombard you with a lot of readings. I can give you a lot of text to cover, but that's not really helping you learn GIS. You really have to learn by getting in and doing it. And so I believe that giving you a notebook and asking you to complete certain tasks within Python that are GIS related, you will learn not only the theory behind GIS, but also the skills and the technique to make you competitive in a modern workforce. And so if you prefer something that's more text heavy, I apologize, but that's not my style and that's not what I do. I'm not going to give you a lot of readings. My slides that I upload are really just meant to highlight the concepts and provide the fundamental information that you need in order to complete the tasks. If you want to delve deeper on those things and you really want to go extremely in depth with theory and some of the other meta knowledge surrounding some of the things we will cover in the course, I'm happy to recommend books to you in order to do that. But you should think of this as a very applied course. Required materials, so you have to have a laptop or a desktop computer that's capable of running Python and GIS software. There's a caveat here. The tool I give you to run Python is Google Colab, and I will have another video up going over how to use Google Colab. But Google Colab, just to give you a quick overview of it right now, as well as your first reflection, is a cloud-based software. So this is a cloud-based, I shouldn't say software, it's a cloud-based development environment for Python. So you can think of this as Google Docs or Word Online for Python. And you can come in with just yourself or a team of other people, and you can all code in the same Python notebook here. And so it makes it very easy for you to share your work with me after you've completed it, and it also makes it easy for me to create assignments and give it to you to complete it. And again, I'll have a separate video going over how to utilize this and how to conduct different functions within here that might be a little bit easier on a local environment. One thing to keep in mind with Google Colab is that it is completely online, so if you don't have access to internet, you're not going to be able to use it. And so in that case, I would recommend, if you don't have access to internet, to download a local Python interpreter, which would be Anaconda. Anaconda you can find pretty easily just by typing Anaconda Python. And Anaconda Python tends to be used for... That's not wow. Anaconda Python tends to be used mostly for data science and other mathematical focused functions and fields, because it provides all of the packages required to do data science, machine learning, and AI when you download it. But it's not required to download Anaconda in order to use Python. You can download just Python. Most computers nowadays already come with Python pre-installed. New terminal. And so if you just come into your terminal, if you're on a Mac, it's going to be your terminal. If you're on a Windows, it's going to be your console. And if you just type Python, you'll get the Python interpreter. And so you can see my Python version. You can see that I do have the Anaconda version downloaded, and I'm using that at the moment. But again, you don't have to use it. And then you can just start doing Python in here. And typing out different functions. Oh, mistake already. Hello world. And so that's fairly straightforward there, depending on how you want to work that. I do recommend for the course, just to keep yourself organized, use Google Colab. It's going to save you a lot of time. It's going to save you a lot of stress. If you know you're going to be somewhere that doesn't have access to internet, I will go over this again when I go over Google Colab, but you can very easily download everything that you've worked on so far and continue working on it locally, and then just re-upload it to Google Colab and continue working on it once you get back into an area with internet. QGIS is a open source GIS software. Again, I don't think we will use it a lot in this course, but for individuals who do want something that's UI guided and wants to play around with that, you're welcome to do that here. All of my assignments will be in Python, so you don't really have to download QGIS. It's really if you just want to play around with something that has a user interface on it. And I can pull... I don't know if it will pull up QGIS on the screen, but just to show you what QGIS is like. And I probably need to update QGIS. I don't open it a lot myself. Again, Python, once you learn Python, it's just so much more intuitive to do GIS and loading this up and doing different things in here. But this essentially gives you a similar interface to ArcMap that you can conduct different GIS functions and tools and processes in. For any data sets required to complete assignments, I will provide those to you. Text and readings, again, these are recommended, they're not required. You can access these if you would like. I made a Python resource, which is essentially a spreadsheet that has a lot of free websites that you can access. It covers Python, but it also covers GIS tools, it covers different data sets, it covers AI tools, and a bunch of other things that you can go into and look around and read about if you're curious about those. So you don't have to buy any textbook for this course. Helpful Python resources for beginners. Again, I make the assumption that a lot of you may not have used Python before. It's not something to really be intimidated about. A lot of people believe that they are not capable of programming or doing code, and I can tell you that that's a barrier that's very easily shot down, especially in today's age, and I strongly encourage you to push forward with it. Once you start using it and once you start wrapping your head around some of the fundamentals of it, some of those more complex things that we'll do, you'll see that they're not as complex as you believe they were. You have to think of programming as communicating with your computer. You're essentially talking to a genie that you're giving instructions to carry out functions on your computer. And that's really all Python is doing. And so I provided a number of resources that you can start reading or looking through in order to get a handle on Python if you feel like you're really far behind and you're very intimidated by it. Again, I don't think it'll be a problem. I will give you sample code. You will have examples to look at. It's not something for you to stress out about because you've never coded in Python. It's pretty straightforward. Assignments and point distribution in the course. So there's 6 labs and there's 12 reflections. Reflections will typically be assigned each week. Reflections will range from Python exercises that pertain to GIS topics that we cover for the week, and they'll also be sometimes just writing. So maybe I'll ask you to give me a couple paragraphs about a concept that you learned that week and how you think you might apply it, how you think you might use it, what you think you might do. Typically, for word limit or word count, I'm looking for a minimum of 250 words. That should be 1 page, single space. You can go over that if you like. I say don't go over too much. And you're probably ranting at that point, but try to stay around the 250 word count. I'm not going to count every single word, but if I only see a paragraph, I'm going to know you probably didn't write 250 words unless it's a really big paragraph. So just keep that in mind. I'm looking for depth. I'm looking for clarity. I'm looking for understanding of the concepts. And if you put all of that into the reflections, then you're pretty good on getting a good grade. For the Python exercises, I'm not necessarily looking for correctness. I'm more so looking for effort. The way I approach you doing things in Python is that if there's something you don't really understand and you can't figure it out, just write out what you feel like you should do and how it should work and what you think the result would be. And typically I'll give you credit for that because that tells me you at least thought it through. Even though you couldn't actually do it, you thought it through, you know how to think it through, and that is good enough for me. The labs are going to be much more in-depth. They are going to focus on utilizing a number of the skills that you have covered over a certain number of weeks. So the first lab will probably come around week 3, and I'm going to be looking at, just to give you a heads up, I'm going to be looking at how well you understand Python. Can you open shape files and read shape files? Can you open CSV files and read through CSV files? Can you manipulate different data types in Python? Can you make a basic map in Python? And so it's going to cover a number of things like that. And then we'll basically go, again, a couple of weeks, and then I'll have you do another lab that'll cover a number of the topics that we have covered previously. So think of labs as being more synergistic of all of the content of those weekly reflections that you will do, this is where you're kind of proving that you understand the material is in the labs. Midterm project proposal, I will explain more about this as we get closer to it. I would expect the midterm project proposal to be up and available to you probably somewhere around week 7, week 8 of the course. Final project and final project presentation. For the final project, again, this will be explained during the week 7, week 8, when the midterm project proposal information is put up. Essentially, for the final project, to give you a heads up about what that will be about, you're going to be analyzing a particular spatial question. So something that is spatially related that is of interest to you. If you're in intermediate GIS, you must have some interest in spatially focused questions and problems. And so I want you to take one of those questions or problems and tackle it. In the past, there have been a few individuals who do not know the exact question that they want to tackle or problem that they want to tackle. And in that case, I do give some kind of ideas, sample ideas to spur them or inspire them. But I would start thinking about that now, just given the heads up that I am giving you here. And then a presentation, this is basically you put your final project, you summarize it, you put it in slides, probably 5 or 6 slides, and you'll make a video recording of yourself presenting it and upload that to Canvas. And that is the majority of your grade, so there's no exams really. I guess you could technically think of the labs as exams, but you're not timed for those, so I really wouldn't make that comparison at all. With the labs, you're really more, you have the time to go through, think through the questions and answer them. You're not, entirely forced to do everything in an hour. The grading scale is there for you to view. I've kind of already provided assignment descriptions. Course policies, there is late work, so it is online and asynchronous, but I do late work mainly because, again, there's a TA that's going to be grading your assignments, and it's really aggravating for the TA to grade through 25 people's assignments and then have 5 people who haven't submitted anything since week 1 suddenly submit everything, and they have to go back and grade through all of that stuff that was submitted. So there is a 10% late penalty. I would say, get everything in by the due date, and we won't have any issues there. If there is something that comes up, you're sick or something else that happens that makes you late, shoot me an email, shoot the TA an email, and again, I'll have the TA's information up. But shoot us an email, let us know so we're aware, and we can work with you on that. Shoot us an email, let us know. Attendance, again, only the labs have an in-person component, and so there's no lecture for you to attend here. Academic integrity, in this day and age, given the complexities around AI and AI copy and pasting and everything that goes along with that, taking code from other places online. In this course, it's really difficult to kind of gauge what is plagiarism and what is not plagiarism. But what I will tell you, if you are just copying and pasting stuff from somewhere, you're technically plagiarizing. Even with AI, it's ambiguous. It's in a morally gray area because a lot of people say, well, if you enter a unique prompt, the output is unique and that belongs to you. I have no aversion to using AI in this course, and I will give you materials that help you use AI successfully in this course. But I would say you're doing yourself a disservice just copying and pasting, because you're not really acquiring that critical thinking component required to truly understand and master the material. So if that is something that you're thinking about doing, I would say don't. It is your class. It is your resources that you have utilized in order to take this class. And if that's how you prefer to take it, it's up to you. But I would say, use those tools as an assistant, not as a replacement for doing your work in the course. Contact the disability services offices if you have special needs for the course. Contact the disability services offices. For the grading rubric, this just kind of outlines some of the information on how we'll be grading different content. And then there's the course calendar. It's important to remember that the course calendar is tentative, so certain things might change depending on weather, depending on life events that occur. I mean, anything can come up that can make this calendar change. For the most part, not really a big deal since this is mostly online. If there are any changes that impact the labs, then we will communicate that ahead of time. One thing that may pop up in your mind as a question I can kind of see coming already is, well, if there's only labs every other week, do I really have to go to lab every week? As I mentioned earlier in the video, the labs are really there to be helpful for you. If you don't need to go to the lab on a certain week, don't go. Plain and simple. If you do need assistance, or you just want further clarity, or you want to talk about some of these concepts with somebody, then go to the lab, bring the work that you've already done and talk about that with the lab instructor. We're not enforcing attendance in any way for the lab. The lab is purely there for you to reinforce concepts that you come across and to get a better understanding of that material. And that about sums it up for this first video here. I do want to welcome you all again to the course. It's your course. Always feel free to engage with me. In online courses, a lot of people just kind of feel like they log in, do the work, and that's it. You're welcome to email me with questions. You're welcome to email the TA with questions. You're welcome to engage with us during office hours. But if you feel like you are falling behind and you need more information, then please shoot an email, request a meeting, whatever you need to be successful in the course. That's what we're here for, and that's what we wish to provide. So catch you all in another video and enjoy. Catch you all in another video and enjoy.